Okay, so we've been working on dividing using fractions, and we did whole numbers divided by fractions, and now we're going to work on mixed numbers divided by fractions. And let's try a couple examples. So I would like to try some easy ones first, and then move up um, to some harder ones. So first, give me 1 second, guys. We're going to try ones that are, that are going to be divided by unit fractions. I don't like that color. So we're going to try one that's going to be divided by a unit fraction. And we know that a unit fraction means that there is a 1 in the numerator, right, of our divisor. We want to be very specific. So we have 2 1/4 divided by 1/4. So when I do this, I know this mixed number is actually going to have more than 2 wholes. It's not going to have 3 wholes, but it's between 2 and 3, this number, right? And so I need to make 3 wholes to be able to solve my problem. Just going to move this, move this out of the way a second. Okay. Making 3 wholes. I usually try to make them a little bit more even, but for now I'm just going to mess around. 1, 2, 3, 4. Again, not an artist, so it's just a representation. Okay, so I have 2 wholes, right? Each of these is 1/4, and I know that I have 2 wholes. 2, 3, 4, right? And 1/4. And I haven't used these, Okay, so I just crossed those out to keep track that this is not part of what I'm dividing. I'm only dividing 2 and 1/4 divided by 1/4. So I want to see how many 1/4 it takes to fill up the space of 2 and 1/4. And I know each of these is equal to 1/4, right? I divided them into 4s. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 1/4 fit into 2 and 1/4. Now I can check my answer using the algorithm. Okay, so I have 2 times 4 is 6 plus 1 is 7/4, right? So I have keep, change, flip. The 7/4 is the mixed number. I converted it to an improper fraction. 7 times 4 is I made a mistake. It's 9/4. I knew I was making a mistake. I was like, no, this is supposed to work out. Oh boy, Miss Piano is tired. So 2 times 4 is 8, plus 1 is 9. Okay, 9 times 4 is 36, and 4 times 1 is 4. Okay, and 36, remember this fraction here means a division symbol, right? And 36 divided by 4 equals 9. So it does check out. Okay, let's try another simple one where we're just working with unit fractions. Or not unit fractions, but we're going to use other simple ones, right? The unit fraction is really easy because you're kind of counting by ones. Okay. And so our next example is 3 and 1/2 divided by 2/3. Oh, sorry, not 3 and 1/2. 3 and 1/3. Okay. And this is still kind of easy because if you notice, my denominators are the same. So when we're working with unit fractions or when denominators are the same, it makes life easier because we don't have to change too much. Okay, and I have thirds, correct? Notice I made 4 groups because I have a little more than 3, so I need to use 4 groups to represent it. And so I have 1 whole, 2 whole, 3 wholes, and now I only have 1/3 of this used, right? I'm actually going to shade it a different color. So this is what I have used. Now I want to make groups of 2/3. Okay, how am I going to do that? I am actually going to circle groups of 2/3. And I have one group of 2/3, and another 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 group of 2/3. How many groups do I have? Remember, this group is all part of one. This one. Okay, so I had 1 group, 2 groups, 3 groups, 4 groups, 5 groups. So let's see if that is the case. Let's see if, right, we're going to use the algorithm to check. And so 3 times 3 is 9, plus 1 is 10 over 3 times, right, keep flip change, or keep change flip, sorry, well, I'm really out of it today. All right, so 10 times 3 is 30 over 6, so that's 30 divided by 6, and that equals 5. So my answers check out. I'm going to try another one, and I'm going to get a little more funky in here. Okay, this one is going to be fun. And so we have 1 and 4, 6. We went over a lot of this in class, but if you weren't here or you just want to review it, which is awesome, I would definitely love you to look over this so you're with us in class. This a little neater. Okay. So we have 1 and 4 sixths divided by 10 twelfths. So I'm going to make 1 whole. And I know I have more than 1 whole, so I'm actually going to make 2 wholes. Okay, so now, make this a little more even. Now I'm going to divide these into sixes because I want to represent my dividend first, right? So I made it into thirds, and then to make it into sixes, I just divide those in half, right? Because 2 times 3 is 6. And I'm going to shade in 1 whole, okay? And I'm going to shade in 4 of my sixes. And I didn't use this, and I'm not using that. Okay, now I have to circle groups of 10 twelfths. I don't have twelfths there. So how am I going to do that? Well, I'm going to do that. I'm going to find the LCM of 6 and 12. There's a couple of ways. Some of you might see that you could reduce 10 twelfths to 5 6, which is fine, right? Or you could use the LCM. I'm really big on using the LCM of 6 and 12, which is 12. And you can also change your group to 12ths, right? Once you find the LCM, you can change your groups. And I know that 6 times 2 is 12, so I am actually going to divide each box into 2. So I'll have 12. And this would have been 12, but we're not using these two, right? That actually looks pretty not that neat, and I can't get rid of it. Nope, can't get rid of it. There is no way to make that neat. Okay. So now I have to count groups of 10 out of my 12ths. Okay? And remember, this is all that I have shaded in. This is like my piece of cake, and I have to find groups of 10 12ths in it, right? And so I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. One group of 10. It actually expands out here. And now I have 1, 2, 3. This line went in the middle. 4, 5, 6, 7, 8, 9, 10. I have another group of 10. So I have two groups of 10 12ths.